So I thought the lesson on osmosis might require a little bit of a further explanation. So I want to make this quick video to see if that helps. So before we start, just a couple of definitions. First of all, solute. When we talk about solute in a solution, the solute is a substance that's being dissolved. So in this diagram here, the solute is, that sugar that's being poured into the water. When we refer to concentration, concentration is how much solute you have. So the more solute you have, the higher your concentration will be. So more solute is higher concentration. Now looking at some other words. Hypertonic, hypotonic, isotonic. If we're talking about a cell in a hypertonic solution, well, that prefix hyper means more or excess. So if the solution is hypertonic, then the solution has a higher concentration of solute. So if I were to draw solute as red dots, then there would be more or higher concentration of solute outside of the cell in the solution than inside the cell. If we're looking at a hypotonic solution, hypo means low. So that means the amount of solute outside of the cell is a lower concentration. There's less. So again, if the red marks are my solute, then there's not so much outside the cell versus the concentration inside the cell. If we're talking about an isotonic solution, well, the word iso means equal. So the concentration, or how spaced out this solute is outside the cell, is going to be the same as inside the cell. Now, if you want to reverse that thought process and talk about the cell itself, if your solution is hypertonic, then the cell itself would be hypotonic. There's less solute inside the cell than outside. If the solution is hypotonic, then the cell would be hypertonic. There's more solute inside the cell. And if the solution is isotonic, then the cell is also isotonic, iso being equal. Now the question is, there's water all around this. There's water outside the cell, water inside the cell. Which direction is water going to go? Water always moves from an area of high water concentration to an area of low water concentration. So in the case of a hypertonic solution, water is going to move outwards. It's going to move outwards in order to dilute or make the concentration outside the cell less. In a hypotonic solution, because there's such a high concentration of solute inside the cell, water is going to want to enter into the cell in order to dilute or make the concentration less inside the cell. If it's isotonic, well, water's still moving, but this time some water moves inside the cell, some water moves out, water moves out, water moves in. The net movement is zero because in an isotonic solution, your particles are already in equilibrium. Now let's look at some of those problems I posted with the beakers. Okay, again, we know osmosis is the diffusion of water through a semi-permeable membrane. Semi-permeable meaning the membrane lets some things in and lets some things and keeps some things out. So if your semi-permeable membrane allows water to cross but prevents the solute from crossing, well, we're talking about diffusion, so water is still going to move from an area of high water concentration to an area of low water concentration. If we're looking at these beaker problems where the circle part is the cell, and then the cell is in a solution in a beaker. Look at the water concentration. Inside the cell, the water concentration is 90. Outside the cell, the water concentration is 85. The water is going to move from high to low water concentration on a net basis, so overall movement. In the second beaker, the water inside the cell is 40%. The water outside the cell is 90%. Water's moving, again, from high to low. The next beaker, 75% water concentration versus a solution of 80% water concentration. Water's going to move high to low. In the next beaker, the water concentration inside the cell and outside the cell are the same. So on a net basis, there is no water movement, or you can say water moves inside the cell and water moves outside the cell at the same rate. Okay, so now let's try labeling what type of solution this is. So we're going to label the solution as hyper, hypo, or isotonic. And remember, those labels talk about the amount of solute. So they talk about the concentration, the quantity of solute. And if we're looking at the solution, then we're comparing the percentage of solute outside the cell in the solution versus inside the cell. So for the first beaker, look at the outside of the cell solute concentration. 15% on the outside, 10% on the inside. There's more solute outside the cell, therefore that solution is hypertonic. There's more of it. Again, we're labeling the solutions, so let's look outside the cell. There's a 10% solute versus inside the cell, there's 60% solute. So 10% is less than 60%. There's less solute percentage outside the cell. Less is hypo. So the solution is hypotonic. The next beaker, 20% outside versus 25% inside. Again, there's less, so that's hypotonic. And the fourth beaker, 25 outside, 25 inside. That's the same or equal. That is iso. So the solution in that case is isotonic. Looking at the last four beakers, we notice some numbers missing. Know that inside the cell and outside the cell, those numbers need to add up to 100. So filling in those numbers, inside the cell must be 90% H2O because 90 plus 10 is 100%. If you have 20% of solute outside the cell, then the amount of water concentration is 100 minus 20, or 80, because 80 plus 20 is 100. Next beaker, 40% solute inside the cell, 60 plus 40 is 100. 30% solute outside the cell, 30 plus 70 is 100. So there must be 70% of water concentration outside the cell. Next beaker, inside the cell, 39% water concentration. 100 minus 39 is 61, so there's 61% solute concentration. Outside the cell, 20% solute, therefore 80% water. And last beaker, inside the cell, 15% water, therefore 85% solute. So now looking at water movement, again, water is always going to move from high water concentration to low water concentration. So since 90 is greater than 80, water will flow outside the cell. 70 is greater than 60, water will flow inside the cell. 80 is greater than 39, water will flow inside the cell. 40 is greater than 15, water will flow inside the cell. And finally, looking at labeling the solutions as hyper, hypo, and isotonic. Remember, we're comparing solute concentration in those cases. So let's look at the solute concentration. Outside the cell is 20 versus inside the cell is 10. So there's more solute concentration outside the cell. More is hyper. So the solution is hypertonic. Next beaker, outside the cell is 30 versus inside the cell is 40. So there's less solute concentration outside the cell. Less is hypo. So the solution is hypotonic. Next beaker, 20% concentration outside the cell versus 61% inside the cell. There's less outside, less is hypo. So that solution is hypotonic. And last solution, last beaker, same story. 25% outside the cell is less than the 85% inside the cell. Less is hypo. So that last solution is a hypotonic to the cell. I hope that helps. If you have any questions, please let me know.